Hello there, welcome back to another episode in our Understanding Mechanical Engineering series. If you haven't watched already, episodes 1 through 5, I would highly recommend that. Here's a quick overview. We just talked about defining engineering, how it relates to other related fields. That was episode 1. Episode 2, we're looking at forms of energy and looking at power and work and force. Okay, and the third episode, doing a little physics, talking about forces and torques. And then simple machines, very important to everything around us. And then just sort of taking a bigger picture look at going from the ideal to real life in terms of engineering. Again, just the goal of this series is to familiarize yourself with these different concepts, or try to keep the videos no longer than 10 minutes. Sometimes it creeps up a little longer, so that you can get a good overview. And then when you go out into the internets, you can have that sort of big picture. Because a lot of times people just sort of dive into the weeds, or maybe it's at the audience is at a higher level. Okay, so today we're going to look at some more physics concepts and just sort of things to think about. Of course, there's going to be a lot of overlap. The next episode will actually talk about how to design a robot for a particular game. And actually, some of that has already been done in the FTC design process YouTube video. All right, let's dive in. So we have the concept of motion, and that's looking at geometry. All right, so that is the actual sort of design of your robot. Okay, sort of how does it exist in space? Then you have the material. Right, this is part of the real life aspect of it. Different materials, they behave differently. They have limits to them. Okay, and you have to sort of balance that out. We had episodes before talking about the forces applied, the work that is done, and also energy. Right, energy conversions. So if you think about what happens in a typical system, and specifically a robot, you go from chemical to electrical. That is called the battery. Okay, and then you have the electrical to the magnetic. That's the motor, which is really, really important. Motor. Then we have the magnetic to the mechanical. All right, the motion that you gets transferred, and that's through things like gears. And then even to the higher level ones, you might have pneumatics, which is air powered, or hydraulic, which is fluid powered. Often you are making a trade-off between force, sometimes torque, because torque is just a force applied over a distance, over around a pivot. And then you have to balance that with distance, or a distance over time is a speed. All right? You're balancing that, you're balancing that, you're balancing material, you're balancing space, and then you're balancing cost. Let's see if we can summarize that. Cost, space, time, and then energy. All right, now you don't have to think of it in this big picture way, but just trying to get you a sense of all these different things. When we're talking about, let's say, energy transfer, all right, we can move it from one thing to the other. If it doesn't transfer all the way, we talk about not being fully efficient, and of course nothing is ever 100% efficient. Or you might actually transform it, you might amplify it. Right, and that sort of goes to simple machines. But there's always a cost. There is always a cost. Your energy, we can also think about it as potential energy. Right, so potential energy can be stored in springs. It can be the material itself. Okay. Some other terms. Sometimes they say actuator, okay, or a transducer. The trans and transducer here is talking about this sort of change in forms of energy. You also have sensors, All right, and actually, sensors are really just a transducer that goes to electrical. All right, what do I mean by that? Okay, it is something that it gathers info about the world and it changes it into an electrical signal. So you can do a touch sensor that usually completes a circuit. Maybe you have a color or a light sensor. It bounces off a light to see how much it reflects back. But yeah, the transducer, through some sort of means of detecting, puts it to electrical, and then you feed it into the, I wouldn't necessarily call it energy, but it's sort of the computational. That's where your code comes into play. If this, then that. Nowadays, there's all these smart home products that will react based on the logic that you give it. You're using sensors, and you're having things respond accordingly. Let's see what else. When we're talking about transfer, the transfer, if this is a top view of your machine, maybe you're transferring the motion to parallel axes. So one thing is spinning, and then somehow it's connected so that the other axle spins. Or you could have it, let's say, on different axes, all right? And so, for instance, if you wanted 2 axes to spin, but they're at 90 degrees, a bevel gear is an option for that. When we think about this transfer, we can also think about transmission, okay, and common elements to do that. We already talked about gears, pulleys, /belts, and then we have chain that's found on a bicycle or a motorcycle, sprockets. That's kind of out of order. That's okay. All right, what else? We also have this area. They call it mechanics of materials, but I don't know how descriptive that is. That's saying that kind of goes back to our material behavior. And so things will wear over time. So because of friction, that's sort of the atomic imperfections over your material. We also call it wear, as in something is worn down, wearing down. That's why you also might use lubrication, such as oil, to reduce the friction. One important thing here that we didn't really talk about is thermal. Okay, sometimes things will heat up. All right, usually that's not part of your design, but you need to be careful about that. Electronics are a really important part. That's its own conversation to make sure you're not overloading your circuit. That's why sometimes you have this thing called a fuse. If the current is too much, this fuse will break, and you'd much rather have the fuse break than a more important component on your part. What else? When we talk about geometry, again, this is just sort of a smattering of concepts here. We can think about what things are pivoting versus what things are fixed hinges. And remember, whenever a force or torque is applied, it's got to go somewhere. It's got to go somewhere. Okay, there's this concept of structural loops, seeing where the force is applied. And then lastly, the space piece. Again, sorry, this is all over the place. This will be the last concept for this episode. I like to think of it as a spatial budgeting. So you're planning and arrange parts. So that's where the importance of CAD comes into play. Okay, computer-aided design. But you can design this whole robot that's laid out, but if you haven't thought about the material, okay, or all these other elements, you're not going to have a complete system. All right, so we're at about right under the 10-minute mark. We'll move on to the next episode where we'll, assuming you have some grasp of these concepts, we'll move on to how to sort of put everything together. Thanks for listening, and we'll see you next time.